I'm going to pick up from our previous discussion about ordinary least squares by showing you an example. I don't spend a lot of time on how to calculate it because by now, once you see an equation, you should be able to put the bucket on the floor and simplify it and figure out how you would do it step by step. This is an example that when I was learning in a class dedicated to ordinary least squares regression, that we were given 9 observations and we had to do it by hand. So we had to take the equation and we had to figure out step by step how to do it. This one question took me, 1, 2, and you notice on the bottom of the second page here I screwed up, so I had to keep going. 3 and 4 pages to calculate 3 numbers. I had to calculate the y-intercept and the beta coefficients for 2 variables. And it took 4 pages of doing, and just trust me, a lot of time. Doing it by hand gave me an appreciation for the difficulties of having multiple variables in an equation like this. So this is something also that ordinary least squares gives us, is that we can have multiple independent variables. At this point, it's probably time to start talking about using computer programs as a tool to do statistics. I hate this idea, but in the hope that Excel is better than nothing, you can actually do statistical analysis in Excel. My main quibble with it is that it's not very clear that Excel was designed to do this, and I don't want you to rely on Excel. It just doesn't look good. But it is the most, I guess, basic introduction to computing programming for statistics that there is. So here's my data set. I've got my 9 observations. I think it was something like birth rates. The unit of analysis is by region. Let's see. One measure here is a measure of income, and this one I think is some version of race. And I got the dependent variable again is birth rate. Now if I want to do a analysis of this data, Excel will actually do it. There's something you might have to turn on though. Excel has a series of add-ons, and they're with Excel, but you have to choose to turn them on. So if I click on the Data tab, over here there's a button for data analysis, but in order for that to work you have to turn it on first. So if you want to hit pause and open up your version of Excel, and I'll walk you through on how to install it if it's not automatically there. Over here in the File menu, you select File and then go down to Options. This data package is an add-on, so click the Add-in button, and you're looking for Analysis Tool Pack. Like I said, a lot of them are inactive, and you can see down here that I have some other ones that are inactive, and I've already activated this one. But to show you how you do it, you click on Analysis Tool Pack, and then you want to click on the Go button at the bottom where it says Manage Excel Add-ins. We'll click Go, and it'll say these are the ones available. So you'll click on the box for Analysis Tool Pack, click OK, and then that'll activate it. It might take a little bit of time for it to start working. But once you've done that, and you're showing up this data analysis button, once you click on it, it'll bring up a bunch of things that it can do. You'll notice there's z-tests and t-tests. I don't see chi-square. I do see correlation, descriptive statistics. So I'm going to select regression, which is the general name for ordinary least squares, and it's saying, okay, for regression, input the y range. So what's your data that's the dependent variable? My dependent variable is this section here. It is, this section here. So I've highlighted it. my X range, my independent variables, that's this section here, right? So I'm selecting all of the X's. There are some options. Do I want to say that the constant has to be 0? That's y-intercept. No, I don't want to do that. You notice I can do a confidence interval as well. I'll make it sure it's the 95% confidence level. And there are other plots that I can put. I can calculate those errors, the plus epsilon at the end. I can go ahead and calculate those residuals if I want. Alright, so I'm going to click OK, and it's going to give me a new sheet of results. And for the output, we're going to focus on those coefficients. So according to Excel, the y-intercept is 36. The beta for x1 is negative 0.003. Let me zoom in. Here we go. The coefficient for x2 is negative 0.12. So let's go back to my homework and see if I got it right. And my answer was 36, negative 0.003, and a negative 1.251. Yeah, I did pretty good. My numbers are about the same. So doing it by hand and then doing it in Excel, like I said, it probably took me an hour to do that by hand, and in Excel it took me 2 minutes tops, and some of that was just figuring out which button to push. So you can do data analysis in Excel as a last resort, only as a last resort. The other great thing about Excel is that everybody uses it. So if you need to, you want to figure out how to do a chi-square test in Excel. I'm sure you could do that. Of course, you could always, do your calculations as bucket on the floor, but here we go. So there are options. Excel should be the last resort, though, because there are better programs out there, programs that are actually designed to do statistical analysis. One that you have access to here at Coastal is a program known as SPSS, and when you look at it, it's just a general Excel-like program. Let's create our variables. I'm going to copy and paste it from our Excel sheet. Hey, there we go. I got to rename these variables though. Okay, go back to the data view. There we go. I'm going to delete this row. There we go. Alright, so now I have my variables in here, and you can cut and paste data, you can save data as an Excel file or a text file and open it up in SPSS. And then what's nice about SPSS is that it has a lot of drop-down functions. So you hit, let's say, analyze. I want to do a regression analysis. I've got lots of options. I'm going to do a linear regression. My dependent variable is going to be y. Oops. Sorry, I got to clean something up. It wants to know what type of variable I have. And when I pasted it, it thought it was a word variable or a string variable. I have to remind it that it's a numeric variable. Let's try that again. There we go. And then put my dependent variables in here. Dependent is y, that's the birth rate. X1 and X2 are income and race. And very quickly I'll hit OK. And it'll pop up some output. And again, focusing on the slope, you'll see this constant is 36, negative 0.003, 1.25. Same numbers that I got on my homework. There they are, negative 0.003, negative 1.25. So I got the same results. SPSS should be in a bunch of computer labs here on Coastal. I'll have to check if it's in the Britton Hall one. I know the Wall lab has it, and the library computer should have it. The next program I'll show you is a version of Stata. Some people call it Stata, some people call it Stata. Stata is the professional software. It is not on campus. It's something you have to purchase a license for. There are versions that students can purchase at a reduced rate. There's a rental option with software, with Stata software, so that you could get it for a semester, kind of like a book. Stata has gone through a couple of iterations. When I learned how to do Stata, I learned how to use a command line function, so it was a lot of programming language and making sure that you put words in the right order. Since I was an undergrad and a grad student, it's changed a little bit, and they actually do allow for drop-down menus. So if you hit the statistics menu, you'll notice that there's a lot of options here. Stata has the ability to edit data. So there's a button that brings up a data editor, and it just brings a spreadsheet up. I've already preloaded my data in here. So we have my Y, my X1, and my X2. Close the data editor. And if I want to run a regression, I can do two things. I could go up to statistics, and it's a linear regression. And it'll give me a pop-up where I can select my dependent variable and I can select my independent variables. And then lots of options if you're doing something unique. Double check that it's got that 95% confidence interval. It's going to report the p-values, test statistics, confidence intervals. Then I hit OK, and it runs it for me and gives me results. I do this usually by using the command line, and the command line structure is very simple. You first tell it what type of model you want it to run, so what test or function are you doing, and then you tell it the dependent variable and then the independent variables. And regression, OLS regression is something that allows for multiple independent variables, so I can put both x1 and x2 in there as explanations. Double check my work, negative 0.003, negative 125, and 36. So again, Stata is giving me the same result. I like to use Stata because I think Stata has a better graphics package. So I can take my data and not only have it the tables and have it give me the correct answers, but I like Stata because I can create graphs to visually represent this data. So let's say I want to do a scatter plot of my variables. Okay. Let's submit that. Stata is going to draw a graph for me. And the other nice thing about Stata, here we have the scatter plot of my dots. The other great thing about this is that Stata has a graph editor, so that I can actually go in here and change the look of this if I wanted to. So let's say I want to change the y-axis. I can click on it and it'll give me options on what I want the y-axis to look like. Let's say I don't like these dots. I don't like circles. I really like hollow circles. I hit apply and it changes them from dots to little circles. You can really customize this to get it to look, and I'm not going to use a color printer. Everything has to be in black and white. So let's find black. Okay. There we go. So now all my dots are black instead of blue. Okay. Let's get out of here. So this is what I use on a regular basis. It's been around for quite a while. The language behind it hasn't changed, and more features get added on. The last program that I want to show you, get out of here, is the one that is free. Like I said, SPSS and Stata cost money. Excel you have to buy as part of the Office suite once you leave Coastal, although you have access to it now as a Coastal student. The one that's free is a program called R, and R is both a computing language and also a program. And as you can see, it's very basic. There's not a lot of drop downs to it. It works off of a command line function, so you have to learn an R language. You start up R and it just gives you a cursor and says, what do you want to do? R is interesting because it's flexible, and there are lots of open source add-ons to this R language. An add-on in R is called a package, and if I'm gonna load a package that's available that I've downloaded. It's called R Commander, and R Commander creates a user interface with drop downs and labels and menus that I can use to help me write the code that R is going to run. So it's a little bit overly complicated, but let's open up R Commander here. That's my R console. I want R Commander. Here we go. I'm a person who puts his taskbar at the top like apples, and so it's not giving me the, here we go. It's not giving me the option to move this window to fill the screen. There we go. Alright, so here's our R Commander, and you need to, it has the ability to open up data sets. So I'm actually going to open a data set. Alright, import data. I have it as an SPSS file because I've already done that. Okay, and it says, where do you find this? Well, here it is. It's this first assignment that I did. Now you notice it creates the R script for you. So it's going to create a data set, and it's reading it from the SPSS file. And so this is what you would have to sort of learn how to do if you didn't have R Commander. And let's take a look at the data to make sure it's there. Here we go. Here's my data set with my numbers. It has all 9 observations. The next thing I want to do is let's run the regression. So I'm going to click on Statistics, and it's going to give me some options. Means, no. Proportions, no. Variances. Let's look at models, distributions. Hypothesis test. Where's regression? Sorry, there it is. It's under Statistics, Fit Models, Linear Regression. And it gives me a new dialog box. It's actually going to create a model. It's going to create an object. My response variable is my dependent variable. My explanatory variables are my independent variables. Got those selected. Hit OK. And again, it writes the command code to create the model, the ordinary least squares regression, and then it gives me the results. So looking at the results, the output, my intercept is 36.3, x1 negative 0.03, x2 negative 0.125. So I'm getting the same results, from each version. R is what professional statisticians are using. I once took a class from somebody, and he was teaching, this was a Bayes class, and he just assumed that we had all used this. And he said, well, of course you use R. It's what statisticians use. We had to remind him that we all weren't actual statisticians, that we were political scientists or sociologists. So there's a little bit of a learning curve. However, with R, there is a great community out there. So somebody created R Commander, and there's a website on how to use the R Commander and how to install it. And with R itself, those packages, those add-ons, there's actually an online community called CRAN, the Comprehensive R Archive Network. And CRAN is where you would download R. Like I said, the great thing about it, it's free. It's what statisticians use. There's a user community out there, so you can get help. There are introductory books that are, you can buy like a $30 book, and it'll show you how to do all your statistics in R. It's something that is worth the investment in time. The other interesting thing about R is with the flexibility, there are add-ons to it. So you can do, let's say you take a class in geographic information systems, right? You take a GIS class. You can do GIS in R. You can make lots of interesting and unique graphics in R. I actually saw somebody one time that used R to make art, do drawings. R is an interesting program. It's free. Unfortunately, it's not very user-friendly on its own, right? Just giving you a blinking cursor here to work with. So it does require you to put in some effort. That being said, you saw how quick it was to run a regression. Even took a similar amount of time as Excel. You'll spend more time downloading it and installing it than you really will getting it to work right from the beginning. So those are your options. You can do statistics by hand. You can use Excel. You could use a program called SPSS. You could use a program called Stata, or you could use a program called R. There are a few more out there. There's one called SAS, S-A-S, of the R language, sometimes known as S+, as another one. Those are out there and available. But as you do, if you take another statistics class that beyond what you've learned here, the next one in a sequence, you'll have to get comfortable with using computer programs, because the math is just too tedious and laborious to actually do 1,200 calculations. You'll want to have the computer handle it for you. I'm going to do one more sort of plug for that SDA website and point out that when you are looking at data at the SDA website, you have the ability to download the data onto your computer. Right, download a custom subset, and when you do that, it'll ask you, all right, do you want us to do it? What sort of file do you want us to create? And also, are you going to use it in these programs? And here's SAS, here's SPSS, here's Stata. So you can sort of download it, and then it's ready to go for variable descriptions and labels of values. So you'll know that a 3 equals Catholic if you download the data definitions for SPSS. SPSS is a flexible one, so you notice that when I used R and I was importing the data file, it said we want to download a SPSS file, and that worked. So this was a quick sort of review of options out there. You've got the break coming up. Since this is the end of the class, feel free to take some time to download this program, this R program, turn on the data package, data analysis package in Excel. Use this for your final papers if you're still working on those, whatever you need to do. But I wanted you to know that now that you have knowledge of statistics, you need to use it, and you need to use these in your future classes, and doing it with the computer will help you have more confidence in your results. At the beginning of the class, a lot of students told me how they just weren't good at math. Well, math is not that difficult. It's just addition, subtraction, multiplication, and division. And if you're not good at math, let's let the programs do it. I'm going to post some links to this CRAN website so that you can download that, and I'm going to let Google handle the rest for SPSS and Excel, but I wanted you to have the links to these this R resource.